Good morning, everybody. Welcome and thank you for joining us for this morning's webinar. Today's webinar will be focusing on precise dosing for the plastics market using pumps. This morning is being led by Nick Daddabbo, Teledyne ISCO's Pumps Product Line Manager. If you have any questions or comments during the webinar, please utilize the chat function within Zoom. All questions will be answered at the end. At this time, I will go ahead and turn it over to Nick.
Good morning. Thank you, Tori, and thank you for everybody joining. So first off, welcome to our webinar on precise dosing for the plastics market using pumps. A little introduction first. I'm Nick Daddabbo. I'm the Pumps Product Line Manager. I have been in Product Line Manager for about 17, 18 years now with different types of pumps companies, and just very focused in many industries, including plastics, food and beverage, oil and gas, and chemicals. So without further ado, let's just kind of get into the presentation a little bit. First off, for today, our discussion will be focused on just how the pump relates to uses in the plastics market. And really what I want to focus on is some things you need to consider or think about when you're looking at the pumps, and then some of the features of some of the pumps that are in the market space or even the Teledyne ISCO offers. I will tell you that, plastics is a very large term, very large market, and there are significant types of variation of applications, types of things you can do with it in that space. Not everything requires the certain type of pumps that we'll be talking about today. Other pumps are out there, or some might not need pumps at all. So, but we're going to just try to zero in where we can. So, where do pumps play in the plastic space? Well, there are many ways to utilize pumps, like I just said a few minutes ago. But a couple applications, or a couple types of things you would do with pumps. It'll provide constant pressure to move material around, dosing of material, colors, etc., or injecting CO2 gas or nitrogen gas into the process. Like I said, there are many types of pumps used in plastics. We will focus on syringe, reciprocating, and peristaltic type pumping technology. Other types of pumps you will see in pumping machinery will be vacuum pumps, especially with vacuum forming as a type of plastics creation, plastic product creation, but also diaphragm pumps do play a role in that space. So as we look at pumps per se and how they would be used, you need to kind of consider a few factors of what you're trying to accomplish. First off, you have to look at the flow rate. How fast do you want the material to flow? And with the different types of pumping technologies on the market, you've got broader ranges, very broad ranges. You have down to 0.0001 milliliters a minute up to maybe 200, 300, 400 milliliters a minute, or even in some types of pumps larger than that. So you have to look at and determine how precise is the flow you need? What is the actual flow rate you're going to need? And then also, you're going to add, I call them reagents, but you could add colors or mixtures into the process. So you need to know, what's the clarity of that type of material, because sometimes the flow rate, if it's too fast or too slow, can change the shape, the size, the color of the material you're processing. A second consideration is pulsation. When you look at, many plastic processes are continuous draw, continuous flow. So pulsation can greatly affect any of the outcome. When you're working with an extrusion process, you need to make sure that your flow is very steady and smooth, because any blips, any tiniest blips, will definitely impact the outcome of what you're producing, the material you're showing, the material you're creating, or even the colors or the types of things you're using. Within the three types of products we were just speaking of, the pulsation rate does vary within those, so you have to understand what your tolerance might be also. Sometimes, you have to get the right color or the right mixture of maybe a UV agent or something like that in the plastic that you're extruding, you need to be very, very precise. Well, that's going to, and very, very pulseless too. So that's going to actually determine the type of pumping technology you would use in the process. You know, sometimes you can add a pulse dampener too. So if you don't want to use a very precise syringe pump, you can maybe use a reciprocating pump and add a pulse dampener, and know that you're going to have a little more pulsation in the reciprocating pump than you would the syringe pump. But if you're okay with that and it doesn't affect your process or shape or size or color of what your end result is, then that's okay. You can add the pulse dampener, and that'll help. Some are external, some are built in. It depends on the type of pulse dampener you're looking for and the actual pump that you're purchasing. Moving on, other things you want to kind of really consider when you're trying to choose a pump or set up a pump in your plastics process is the pressure. I mean, the pressure capabilities are very important. Sometimes in some applications, I know in the rotational molding aspect, pumps are used just to provide just to provide pressure, to push all the little materials out into very intricate rotational molds themselves. So you want to make sure if it's something that's very detailed, or the mold is very detailed, that all the plastic gets into all the crevices possibly can. So you provide the back pressure of some CO2 or nitrogen to make sure that gets out, all that plastic gets out into those crevices. That would have to remain constant. So it cannot have any fluctuations or dips or changes in that. So you really want to look for pumps that can do that. Footprint is a big deal. I mean, the pumps change. The pumps vary from size and shape. You'll see that shortly. But you have to look at if you need something that's very precise, you can live with a little pulsation. Do you have the room where the machine is or with the process is to set a syringe pump? Now, you know, there's different ways to do that, but you could also, you know, if you don't need the extreme precision, you can go with a smaller reciprocating pump that can sit on a shelf or be built into the actual extrusion machine. So those are things you want to look at and consider, because sometimes that doesn't get thought about until after you've purchased the pump. Viscosity is another thing. Many plastic materials or chemicals that we input into the process, or the colors, the paint, can be very viscous. So you need to make sure that the pump can handle moving it and it doesn't gum up or make things stick as far as in the process. Again, that's not really pulsation. That's more of the viscosity will affect the reciprocating pumps typically have check valves. Check valves do get gummed up sometimes and don't work smoothly. So you need to make sure, okay, is that the right pump for the material you're trying to shoot and to move? Okay. You know, other considerations, you need to move the pump around. I mean, we talked about setting it on the machine. Does it need to be able to be disconnected and used in another process? If you have a couple of different extrusion machines, you know, you only have one or two pumps to share, do you need to be able to do that? Is the pump scalable? Sometimes you have a small process where you're doing it and just testing out the right color mixture, the right size and shape of the bubble, the right size and shape of the foam. Can it step up to be, you know, can it be moved up to say, okay, I need to produce much more of this? Or do you need to replicate that same line 10 times? You know, is single or dual head? That's definitely a very interesting question, because you know, dual head is more of like a continuous flow, so you're going to get a little less pulsation in that aspect. It's not going to be as precise as it would be for like a syringe pump, but a dual-headed reciprocating pump does kind of minimize some of the pulsation application in the application. And then if you add a pulse dampener, then you're getting it down as tight as you can. So still not as strong as a syringe pump, but it'd be very close. And then what other stuff do you need? You know, what is the impact of the project cost? That's all stuff that we're all familiar with knowing how to do. But you want to look at and you think about how you're going to be using the pump. It's not just say, hey, there's a pump that does this flow rate, let's just buy it. You got to really consider, you know, can it get to the flow rates you need, and what do you sacrifice to get to that flow rate? Are you sacrificing pressure? Are you sacrificing the ability to move a heavier, more viscous material? Those are things you need to weigh out when you're laying out your process. So let's talk about a couple applications where we currently participate. You know, chemical color additive to the extrusion process, especially twin screw extrusion. We have a bit of a application to diagram a little bit farther in the presentation to show you how we play there. I mean, it's color additive. It's also adding CO2 to the process. I mean, there's many different ways we participate with extrusion. CO2 usage for foam processing. We have an organization up in Toronto, the University of Toronto, does a lot of research with foam creation, and they use our pumps in their processes and in their research. Many of their doctoral students will present to vendors and customers, and they prove their thesis using the syringe pump. Polymer pulling, especially hauling out polymer tubes. We have a couple universities across the country. Georgia Tech is one of them, and University of Nebraska-Lincoln here is doing research on using polymers for different types of applications. And they're actually using two of our pumps to kind of create the polymer tube and then inject a fluid into the middle to hollow it out, so then the tube can be used for something else. So these are a couple applications. We're going to talk about some of these as we go over the next few slides. Here's one here is for polymer creation. You know, this application here, you know, any of our pumps, and you can see right just above the bore fluid there, the little diagram says syringe pump. You know, it's universities, as I said, are doing the research for polymers across the globe, and they're employing our Teledyne D-series syringe pump in that process. Why? Well, there's true pulseless flow. We talked about how if you're pulling a polymer strand, you need that to be smooth and pulseless as possible. You can't have a jagged or blips or anything else, because that would ruin the material or ruin the actual polymer. You know, it can pump liquefied gases, and it's very precise down to the flow rate. So that's very, very important when you're looking at polymer creation. Some of the uses for these polymers, you know, we talked about creating the polymer tubes. Well, you can tie them together and use them in desalination plants and other types of things. So let's even go to the next slide here. You know, polymers are everywhere. So you look at, you know, there's a jacket up there on the right. A lot of the applications, a lot of the companies like Patagonia, Gore, and places like that will use little microfibers within the clothing to help waterproof the product. So there's some polymer being created there. You've got in the lower right there with the shirts, the spandex that Under Armour is developing. There's synthetic polymers that kind of tighten the shirts, take the wicking away, and now they're even looking at using those shirts to be able to monitor your health. So there's a lot of future research going on into using polymers for other types of applications. You know, and to the left here, we talk about desalination, tying a bunch of polymer tubes together and making a big, like reverse osmosis tube out of it, and have the water and everything go through that. So just in polymer creation, there's a lot of applications out there that, for one, we just talked about, and this diagram right here shows where syringe pumps can be used or applied. The next type of application up there is foam extrusion. This is actually a research paper that was done in University of Toronto. And they used, and you can see right there in the upper right of the diagram, they're using the syringe pump to push CO2 into the extrusion process to help create the foam and inject it. And then you can use it. They're also doing research to inject nanoparticles into the material to reinforce it, like carbon nanofibers. Again, the precise flow rates are very important here, and the ability to pump CO2. So these last two applications are very focused on the syringe pump technology and how precise the flow rates and pulseless they are. But this is part of the process, part of the foam extrusion process, something you need to make sure you stay aware of. A couple of things that come out of the foam extrusion, the insulation in airplanes and some cars down below, the sound deadening, etc. Sneakers, soles, many different organizations or companies create soles with compressed foam, and obviously styrofoam panels. They can be used anywhere, right? So these are just a few examples of everyday things that are using the process where our syringe pump supply. As we keep going here, we talked about earlier about nanofibers or injecting nanoparticles into a material to reinforce it. You know, the whole carbon nanofiber reinforcement of products or walls of cars is very real, and it's a process, something that's happening quite a bit. Again, we go back to the University of Toronto is doing some work in this space, and again, they needed the precise dosing and pulseless flow. So there we go. It's perfect for a D-series. As we look at other applications, you can see in the upper left there, that's a nanofiber reinforced sheet of like plastic or material to be able to be twisted and still maintain its strength. Down the lower left, you've got carbon nanofiber reinforced bodies of a tractor. They're doing it in cars and just making them stronger but lighter, so they're able to get more gas mileage out of them. In the lower right there, you have some just little like impeller blades that were made from carbon fiber. And in the upper right is just a little example of aerogels, which is some of the research that we're doing here at the University of Toronto. So there's 3 applications, and there's another one coming up here shortly that shows you how and where you would use a syringe pump for creating some of the products, or something like the foam extrusion, etc. Next one we have, injection molding. This is actually a application note we have that is showing you how using the pumping CO2 to be a blowing agent through the extruder. Some of the other things that would happen here, you could actually use, in this case, you could use a small reciprocating pump that would add color or UV protectant to the extrusion process. So instead of worrying about the pellets and everything for the color, you can just inject liquid into there, and it'll get smooth and run through the process. Here are the few, obviously a whole ton of things we use injection molding for. So, car covers, you got chairs, tables, all this stuff. So, and you can see all the different colors there. So there's definitely a lot of opportunity for that. Some other applications that we haven't really talked about. It's not necessarily plastics, but it is kind of in that vein, is using the D-series or a Reaxis with a pulse dampener to put a protective layer of silicone onto semiconductor wafers. That's a very smooth, straight process, and as the conductor wafers come out, they get coated with the silicone. And then, as I said earlier, they're providing pressure to the rotational mold machine to ensure the material gets all into the detailed crevices of the product that you're trying to create. Because sometimes as we start to use more plastics and find more ways to use plastic material for things, the molds will get much more intricate. So as we kind of tail up to the end here, let's talk a little bit about the different pumping technologies, and let's talk about advantages and disadvantages of them, and try to relate them back to the plastic space. So first and foremost, we're going to talk about syringe pumps. Shocking, right? Because we talked about the examples in some diagrams previously. Well, syringe pump technology is a long-lasting design. It's pulseless. You have very, very precise flows. You can get in some really high pressures. You really won't need too high of pressures in the plastics process from a pumping standpoint, but it's there if you kind of needed it. Some of the drawbacks are there are expensive initial investment. Not going to lie about that. But so is a machine of when you're looking at an extrusion machine. That's not exactly cheap. So the product will fit in there nicely, and it's got a large footprint. So you need to make sure that this pump will fit onto either a stand or fit near where your process is. And as we look at this, here's a whole swath of different sizes and flow rates and max pressures we have for our D series. You can get down extremely low for precision. So you have that capability within our product line, and you just need to pick the correct one. Next type of technology we'll talk about is reciprocating pump technology. You can get up to some pretty high pressures there, up to 10,000 PSI or even more. It's a little bit lower flow. It's a very proven, common design. Very simple, kind of like a train engine, right? Chugging back and forth. The drawbacks here is it struggles with viscous fluids. As we talked about earlier, viscosity is something you really need to make sure you consider when you're selecting the type of pump you want to use. Reciprocating pumps typically use check valves. They do tend to jam up sometimes with some sticky or viscous fluid. So if you're really concerned, or if there's even an outside chance that the viscosity is going to be kind of touchy, you need to maybe look at either a different pumping technology, or be aware that this is going to happen and build in something to your process to be able to check the valves or to keep things clean. And it's not pulseless. Okay, you see, when the pulseless continuum, the D series, the syringe is going to be the best, and you move into reciprocating pump would be next. You can add a pulse dampener to help that, but it will not get it down to the levels of the syringe pumps. When you look at what Teledyne ISCO has, we have two different types of reciprocating pumps that would be really good for this market. Here is just a very basic model, very basic model. It's built to just move fluid, move material. It's 100 mils a minute, 2,000 psi with an optional pulse dampener. Very generic, all-purpose pump, low cost, and will fit very nicely on an extrusion machine or any machines you have nearby. The next one here we talk about is it's our PR series, and you get up to about 300 mils a minute, about 4,000 psi. So you have a couple options. This is a dual piston one, so we already talked about the continuous flow. This will have better pulsation capabilities or restrictions than the M1. So this is something to consider if you need to move those types of flow rates. The last pumping technology we'll talk about here is peristaltic technology. So here's one, this is quite interesting. This is actually designed to be, this technology is designed to move very viscous fluids, sticky, kind of slurry type stuff. So it's very simple roller squeezing something through the hose. There's no wetted parts. You can change the head if things get stuck up. You can change the hoses. Very low downtime, so easy to maintain, easy to change. You know, disadvantages sometimes with the materials you're pushing through, along with maybe the viscosity, the hose life wears. Because if it's harder, it takes more pressure, it takes more effort to squeeze the hose will show some more wear. It's not pulseless. You're not going to get any, if pulsations are concerned, you're not going to get down to where you need to be. But if this is just simply moving some material to a spot or injecting into the machine, and you don't need it to be, and the machine itself will do the dosing out, you're fine. This will be great for you. Typically, they're smaller footprints, and they'll fit on machines quite well. This is just the last slide, just talk about the advantages and disadvantages. There's two types here we did not chat about because they really do not play too well in plastics, but this is just a slide to show the advantages and disadvantages of different types of pumps. So with that, folks, that's going to bring an end to this webinar. I'd like to see if there's any questions out there, and then we can go from there. Oh.
If you do have questions, feel free to use either the chat function or the Q&A function in Zoom, and we can go ahead and work through those.
So, Tori, we did get one question come in that was asking about, for D-series products, how does it handle viscous? Can it handle viscosity? And my answer to that is, well, we do have a version of the D-series that is a HV model. It's a high viscosity, so it has a little bit higher openings, a different angle at the top, so it allows the material to go in at a different angle and go into a little bit smoother. So you're not stuck with just the peristaltic to pump highly viscous fluids if you need to. We do have options in the D-series that if you need the precision, you need to be very precise and pulseless, you can use that there also. See, anybody else come up with anything? Any questions? Or I got one more. We know the customer said that they noticed, or the gentleman said that they noticed that this D-series is very large, and they don't necessarily have all that space to be able to dedicate to where the process is. So so let me help you with that. You can mount this different ways. You can mount it upside down, sideways, if it fits better that way. When you look at syringe pumps, the controller can be corded out so it's off somewhere else, so you can gain space like that. So you have a full capability to mount that pump upside down, sideways, horizontal, whatever you like, to try to fit it into your space, into where you actually have your process or your machine set.
Okay, while we wait and see if there's any more questions that come in, I just wanted to take a moment to let you guys know that this webinar is being recorded. So this will be sent out to all excuse me, attendees later on this week. So look out for that email. I also wanted to let you know that we have another pump webinar coming up in the month of January. We are going to be doing a webinar every month, so be on the lookout for those emails. January's webinar will focus on selecting the right pump type for your application. That webinar is taking place January 15th. You will receive information later on this month through email to register for that, so be on the lookout for that as well.
Okay, I don't have any more questions that came into me either. I want to thank everybody for their time today, and I hope you were able to pick up a little bit of information. If you have any questions or anything, feel free to reach out to myself or any of maybe your local sales rep too.
Thank you, everyone. Have a great day.